the last video, I went step by step to help you solve these stoichiometric problems using chemical reactions. Here, you're going to take a moment and pause the video after I read the question, solve it on your own, and then I will come back and make sure you get the right answer. The nitrate ion in potassium nitrate is changed to the nitrite ion in potassium nitrate is changed to the nitrate ion by the action of potassium permanganate in sulfuric acid solution by the reaction given below. 5 moles of potassium nitrite reacts with 2 moles of potassium permanganate and 3 moles of sulfuric acid to produce 5 moles of potassium nitrate, 2 moles of manganese sulfate, and 1 mole of potassium sulfate, 3 moles of water. How many moles and how many grams of potassium permanganate are needed to carry out this reaction on 11.4 grams of KNO4? Use the steps that I showed you before to solve the problem, and we'll come back and make sure you have the right answer. Let's make sure you solve this problem correctly. The question is asking for the number of moles and the number of grams of potassium permanganate that is needed for the reaction of 11.4 grams of potassium nitrite. All right, well, before we solve this problem, we need to figure out what we need. I'm given grams, and I need to know grams. So I'm going from grams of A to moles of A to moles of B to grams of B. So in order to get from grams to moles or moles to grams, I first need the molar mass of both of these before I even start solving my problem. So the molar mass of KMNO4 is equal to 158.02 grams per mole. You can do that calculation on your own to make sure that I did that correctly. And KNO2, the molar mass, is equal to 85.11 grams per mole. Did you get that right? Hopefully you did. Now, we know that we're going from grams of A to moles of A to moles of B to grams of B. So we need molar mass, and we need a mole to mole ratio based on our balanced equation. So I'm looking at potassium nitrite and potassium permanganate. All right, so that's the ratio that we'll use. So given 11.4 grams, need grams of potassium permanganate. So starting with what I'm given, I was given 11.4 grams of potassium nitrite. I used the molar mass to determine the number of moles of potassium nitrite. Next, I need to compare the moles of potassium nitrite to moles of potassium permanganate. Since potassium nitrite is on top, I need to put the number of moles of potassium nitrite on the bottom and 2 moles of potassium permanganate on the top. Let's correct this right quick, because the first problem we're looking for the number of moles. Okay? The problem, we set it up the exact same way. I just stopped short right here. So grams of potassium nitrite cancel, moles of potassium nitrite cancel, and I'm left with moles of potassium permanganate. And I get 0.0538 moles of potassium permanganate. given this information, we can just simply use the number of moles to figure out the number of grams. We just split this four-step problem, well, four-step problem into a three-step problem. So now we want to know the grams. And we're given 0.0538 moles times our molar mass, which is 158.02 grams per 1 mole. And our answer is 8.46 grams of potassium permanganate. All right, one last problem for you to try on your own. Calculate how many grams of iron can be made from 16.5 grams of iron 3 oxide by the following equation. 1 mole of iron 3 oxide reacts with 3 moles of hydrogen to produce 2 moles of iron and 3 moles of water. Pause the video, solve this problem on your own, and you can come back and check to make sure you got the answer correct. Okay, let's check your answer. Before you can begin, you first have to calculate the molar mass of iron 3 oxide, which is 159.7 grams per mole. So our question is asking how many grams of iron can be made from 16 grams of Fe2O3. So essentially, this is the grams of A, moles of A, moles of B, to the grams of B, right? And for those, you need the molar mass of Fe2O3, and you need the molar mass of iron, which we get from the periodic table. So we're given 16.5 grams. We're given 16.5 grams of Fe2O3, and we need to know the number of grams. Okay, so to calculate the number of grams of iron, we need to start with what we're given. We're given 16.5 grams of Fe2O3, and we need the number of moles of Fe2O3. So 1 mole of Fe2O3 is 159.7 grams of Fe2O3. Now we need to convert from moles of Fe2O3 to iron. So based on our balance equation, 1 mole of Fe2O3 must react with 2 moles of iron. And then to find the number of grams of iron, we use the molar mass of iron. 1 mole of iron is worth 55.85 grams. Let's make sure that we cancel out all of our units. Grams of Fe2O3 cancel, moles of Fe2O3 cancel, we get moles of Fe, and we end up with 11.5 grams of iron.